Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. I'm really excited to be interviewing another person from Hugging Face in this episode, Victor Sanh, who's a research scientist at Hugging Face. This is part 2 or second release of the Hugging Face series. So do check out the interview with Julian Chaumond, who's the CTO of Hugging Face, if you haven't or if you're interested. In this episode, we talk all about Victor's journey into the field of NLP and machine learning, broadly speaking, and delve more into research at Hugging Face, especially DistilBERT, which is the most recent research by Hugging Face. We also talk a lot about open source and research in general. Victor shares his amazing viewpoints for NLP research in this interview, so I'm really excited to be sharing this. Without further ado, here's my conversation with Victor Sanh, research scientist at Hugging Face, all about DistilBERT and research in NLP. Please enjoy the show. Hi everyone, I'm really excited to have another person from Hugging Face, Victor Sanh, on the show. Thank you so much, Victor, for joining me on the podcast.
Hi, thank you for having me. It's a pleasure to be here.
It's really an honor to have you. I thought I'd like to use Hugging Face transformer model again to generate your intro. May I read it out if that's okay with you?
Yeah, I like that. Go.
So this time I used Distil GPT-2. Last time with Julian, I had used GPT-2. The prompt that I gave to the model is Victor Sanh is a research scientist at Hugging Face, and it came up with Victor Sanh is a research scientist at Hugging Face Research Institute in New York City and has led a number of open source projects that have been named for his work. He's also co-founder of OpenAI Foundation and is a founding member of International Open Source Society, IOF, and Open Technology. His interests include computer vision and NLP, open technology, cryptography, computers, software, and robotics. He's also an open source software engineer and researcher. Seems right.
I love this description. Actually, like part of it is actually true. Like not the OpenAI part, definitely not. That's not me.
Yeah.
But like, yeah, I started like with computer vision before doing NLP. So yeah, part of it is definitely true. I promise, like I didn't like put anything like on myself when training this.
Okay. But I'd definitely love to know more about your background before we talk about research at Hugging Face. So could you tell us how did you get interested in machine learning? I found out that you also took up a bunch of machine learning courses during your university days.
Yeah. So basically, I have a background in mathematics. So I did pretty much all my studies in math. So I studied like algebra, topology, optimization, like probability, financial math, like a lot of math.
Wow. Okay.
And so like I guess like my first project in machine learning was doing computer vision. So at that time I was working on like a project like we were doing like 3D object recognition.
Okay.
So using like RGBD input, so like the D, so RGB, like and the D stands for depth.
Okay, gotcha.
That's the kind of like sensors you have like on like recent iPhones.
Okay.
So using like these RGBD inputs to recognize 3D objects. So that's how I kind of started machine learning, and then like I did a little bit of machine translation. This was like my first step into NLP. And yeah, like now I'm like more working broadly on NLP at the stack. I've done a lot of like conversational AI, obviously. But yeah.
Got it. You're a research scientist at Hugging Face. Can you tell us more about the work that you're currently handling and what does a day in your life currently look like?
Yeah. So I guess like I work on like, let's say I work on two different things.
Okay.
So Hugging Face is also building a product. So we're doing conversational AI. That's how this company started. So part of my time is actually, building machine learning stack for the product. So I cannot let like the effort, like putting machine learning into the product. So building the new models, putting into production, monitoring the server, etc. So that's one of my role. Now the focus is more like doing research. So what I mean by research is like science in general. So it can be like contributing to transformers, our like main library. But it's also like working on fundamental research papers, writing blog posts as like a teaching opportunity, like reading papers. So yeah, I try to balance like right now my focus is really like on science. So I try to balance all of it, and depending on like the timeline on the different projects, like try to prioritize all of this.
Got it. You mentioned the Transformers repo. So TensorFlow 2.0 or PyTorch, which is your favorite right now? It's a tricky question.
Honestly, yeah, it's a tricky question. I feel like I shouldn't answer, like just not to like offend anyone. I started machine learning doing TensorFlow actually, and then I switched to PyTorch. So I guess like I use both. Like a lot of the code, like the code we released, is actually in PyTorch. That's like how we like started building things. But like the vision, like on Transformers library, is really to be agnostic as possible on like the framework we use, either TensorFlow or PyTorch. The idea is here is like to bring value to as most people as possible. Right. And so that like the framework is not like a barrier like to use our libraries.
That's amazing.
I mean, like we already implemented in Transformers now. It's not PyTorch Transformers anymore. And like super excited to see like how people use it, and like already people like opening issues. So people are actually using like the TensorFlow implementation. So
me as a fan and also user, I'm definitely more excited about it as well. Now, coming back to the research aspect, so a common question is, how does your research pipeline look like? How do you think of a new idea? How do you approach a new problem? Maybe quoting the DistilBERT as an example here.
Yeah. So I guess like the DistilBERT paper like came out of like this general trend like in the community, in the space in NLP of like training, and like more specifically pre-training super large transformers, and these transformers were getting larger and larger, and like a lot of us, like not only me, but we're kind of tired of seeing this trend. Like for many reasons, like for just to cite one, like how do you handle this super large models into production? So no one can actually use like 1 billion 5 meters in production. So just from a production point of view, you want to have something more efficient, more like production friendly, something more maintainable, etc. So I guess like the first step, like in terms of research, is to work on something that really excites you and that interests you. So like the most recent one, yes, definitely is DistilBERT.
For sure.
But like I've worked on multitask learning before, like other topics too, conversational AI. So it's really about like finding something that excites you. And the second point is what could be like from a research scientist perspective, I would say would you be like proud of yourself?
Hmm.
Would you be like excited if you were to read like the paper, like your contribution?
Right. Got it.
I mean, like you're probably gonna write something, an implementation, a paper, or whatever like the format is. Would you be like proud of like this work at the end? Like, would you be excited about this paper if it wasn't you who wrote it? Would you be like, okay, this is a real contribution. I do see the trend here, etc. So trying like to find like this intersection between what excites you and what can really bring value to the community.
That's amazing advice. So you mentioned you should be excited about the project. One thing that I always get worried about is in a passion project, you might not be able to see when should you end a project or when should you continue exploring, because nothing works in machine learning until it does. So how do you
Yeah,
decide that?
yeah, that's a good question. Well, like if I had like the perfect answer, I guess like that would be great.
It's another
Unfortunately, I
question.
don't have it. Well, like obviously, when you start a project in machine learning, you have to factor in that like the first iterations won't work.
Hmm.
Like otherwise, you are probably a genius. So just like be aware that like the first iterations like won't won't look like the final product, like the final model or whatever you call it. So it's really important like to have this in mind when you start. And it's also like a question of determination. So you know that it's going to fail, like you know that it's going to fail several times, multiple times.
Yeah.
How do you handle like its failures? Like do you know run out of ideas from these failures?
Hmm.
And that's probably like the moment when you should, okay, I should step back, step down like from this, like just take the time like to have a better view on this, like just have a better like helicopter view on this and
Yep.
clarity. And maybe like in 2 or 3 months, you'll have better ideas that will come like from other research interests and that can feed like your ideas and like come up with like something different.
Where you mentioned you work in a remote situation. So, any ideas that you picked up how to best work with the remote team? Because remote work is in itself a challenge when people are distributed across different time zones. So, any tips or tricks there?
Communication.
What's
Yeah,
that?
yeah, communication is at the center of like because it's easy. I guess it's easier to collaborate when you like face to face.
Yep.
So we have like our main office. He's in New York, so it's
Mhm.
like definitely easier like to like collaborate.
Yep.
But we also like as I said, we have people in Europe. We have like to be really, I would say, intentional in the communication and to be really clear on right away on like who works on the what, who is leading what, who is like taking the lead on the timeline, on like prioritizing things,
Right.
etc. So we have to be really intentional in that. But I mean, like we managed to like do it pretty well. So I think we collaborate like quite well in the sense that having like this natural like remote setting like in which like uh, the overlap between Europe and New York, so the East Coast is like the morning here and it's the afternoon, like the end of the afternoon in Europe.
Right.
So what it means that um, you can do your like I can do my day, like my whole day, like pretty um, peacefully without being interrupted every 10 minutes.
Mhm.
Like write something for like the people in Europe, and when they get up, they have like what I wrote and like my questions and like the points like I raised, etc.
Got it.
And when I woke up, like when I'm waking up like the next day in New York, then I already have like answers, etc. So you have like a rhythm and dynamic that like is naturally introduced by having a remote and non necessarily overlapping time zone.
That's amazing advice. How do you exactly factor in such that the tasks don't become deadlocked? Now,
Hmm.
coming back to research, if I may, Hugging Face is like the Apple of NLP. Maybe not the current one with the kitchen stove design, but maybe the older one. True innovators in open source and research. Could you tell us more about your latest innovation, DistilBERT? It might be a little technical, so maybe if you could give us a 50-foot overview.
Yeah. So DistilBERT stands for distilled, like using distillation BERT. So the idea is compress BERT. So
Okay.
BERT, like the smallest BERT, is 12 layers. It's about 110 million parameters.
Okay.
So we managed to compress it to using 40% less parameters. And it also means that since the model is smaller, it's also faster.
Mhm.
So it's like on average, it runs twice faster than like the original BERT. And it actually had a pretty good performance. Like it's like 97% of like the original BERT, like on the glue benchmark on the dev set. But like another advantage of that is that it's actually cheaper to train. Like distillation is this idea that you have a teacher and you want to train a student,
Right.
and the student is trained to mimic, like to reproduce the behavior of the teacher. So using this technique, we can like train like a smaller transformer model, a smaller BERT, in a way cheaper manner. So it
Mhm.
doesn't take like as much compute. And it's actually also faster to train.
Got it. Uh, there's a question from the AMA section by @logesh_umapathy. Uh, which of these approaches are best for distilling on a task, specific use case, distilling transformers on language model task, then transfer learning on specific data set, or directly transfer learning the transform on target specific task, then distilling it?
Okay, yeah, that's a good question. That's a really good question. I would say it depends on how much data you have.
Okay.
Um, yeah, like the first answer is on how much data, how like the volume of data training data you have.
Let's
Like
assume
a lot of,
we're talking about
sorry.
IMDb, for example. So IMDb sentiment classification.
Yeah. So yeah, let's say we're talking about IMDb, but like a lot of papers, like recent papers, including recent papers, like some of them are actually iClear submissions,
Mhm.
um, show that the pre-training, like they study like the interconnection between pre-training and distillation, and show that pre-training is actually super important. And so what we do in DistilBERT is actually we pre-train transformer language model by distillation, and
Okay.
then we can fine tune it like a classical BERT, like because it's also faster, it's cheaper to fine tune.
Mhm.
But like this pre-training part is definitely super important. So if you have like just a little bit of data, pre-training, so doing transfer learning basically. So have you something pre-trained and you fine tune it on like your specific task. So doing transfer learning is super important.
Got it.
And like can like boost your performance. If you have much more data, like a really big training data set,
Mhm.
I would tend to think that like training from scratch can lead to like pretty competitive baseline.
Okay.
Yeah,
Um,
can lead to a pretty competitive baseline. Then there's another question like what kind of architecture are you using? So there's this question of like distilling or like trying to compress a model into another inductive bias. It
mhm.
means that, so BERT is a transformer-based model,
Right.
but what if you're trying to put it in LSTM? And honestly, that for me, I don't have like a really good answer of like how it works. Like actually, does it work?
Mhm.
Like transferring a transformer to an LSTM, like because you're kind of changing like the inductive bias. That's an
Right.
open question for me today.
Okay. So DistilBERT is not the state of the art across benchmarks, but it's definitely much more lightweight across the Muppet Street. Did you try any inference benchmarks or maybe some intuition on how frictionless will it be to put it into production?
So yeah, what we basically compared is like so different kind of production settings. So both on CPU, like having a server on CPU, having a server on GPU,
Right.
and compare the inference times. And on average, like both on CPU and GPU, it was like twice faster than using the original BERT.
Wow. Okay.
So yeah, we do like and we tested like both like recent architectures like for GPUs like V100 or like more basic infrastructures like a K80, which is like a really basic GPU. Yep. And also like in the idea of like pushing like the research directly to the production, we also tested with computation on device. So like we basically tested on iPhones. Okay. And yeah, again, like it's like it's smaller, so like just like it doesn't take as much memory space as like the original, and it's also faster. I think like if I remember correctly, like 60 or 70% faster on like iPhone 7.
Okay, iPhone 7.
iPhone 7. I think we have like a benchmark on like more recent, like iPhone 11, so the latest one. I don't have the figures in mind, but you should check like the Swift Core ML repository, one of our GitHub repository. Like so Julian and Lissandre led the test on that, and I believe like they include like the results. Sorry, I don't have like them like on like here, but
we'll have them linked in the description for the audience.
Super, great.
Yeah. Talking a little bit about iOS, Hugging Face is, of course, it's already shipped these models on iOS, which still is completely mind-blowing to me, even though Julian has already talked about it. What are your thoughts on edge inference and any research in that domain that's exciting to you outside of DistilBERT, of course?
Yeah. So yeah, there are actually a lot of like recent research on like how can you compress like these large models that it can be like around distillation, quantization, but also around like how you can tweak architectures like from the beginning. So how to include more sparsity into the training, into the transformer model, like at training time. So like just to cite a few of them, there is Albert, like this paper from Google, which is doing a really great job at like compressing. That's pretty impressive, like the result they have. Another IQ submission is called Layer Drops.
Okay.
That's not the real title. The real title is like reducing number of layers on demand. Okay. Like the method introduced is called layer drops. The idea is like extend like the dropout, but to the layers of the transformer. That's like the high level pitch. So I'm really excited like to see all these works on trying to compress the transformer models, like how trying to understand like what kind of sparsity we can reach, where, like in which layers, why we can do that. Like, does it help to generalize? Does it help like to train faster, etc.? I'm super excited to like to see all these developments. I think like they are like, I count in like I just came through like the archive submissions, and there are around like 20 or 30 submissions around this topic. Okay. So I'm super excited to see that. One of the reasons that all these compression techniques and methods and studies somehow have been put aside, like in the research community. At least it was not like as trendy as doing transformers. Yeah. And I believe that having this kind of studies can also help us like to better understand like why transformers work, what kind of inductive bias, what kind of like structure we are like actually learning during training. and it can help us like to build like better models, like to better analyze these models. So,
Yeah.
like, yeah.
For sure, because that's how you get it into the hands of people, by putting it on their phone, not by training it across a huge number of GPUs and only limiting the inference to that.
Yeah, yeah. And I think like, can I be like real and honest with you, just real quick? Yeah, like one of the things that really excites me, like now, like as a community, is not like really doing research for doing research. What um, 2019 is super exciting because we're like reaching a level of like production research to production.
Yeah.
We're starting to really smooth out like the all these advances, all these techs, all these new models, like from research to production. And that's something that's really exciting me because like the goal of what we're doing is not doing research. The goal of what we're doing is bringing machine learning to so that we can impact other people's lives. So we
Yeah.
can impact like the life of my mom who like barely knows how to use her phone. And like she's amazed of like, yeah, I'm typing something and like my phone is actually trying to autocomplete me. Yeah, that's machine learning. So so what we're really doing here is like building the tech, building the technologies, building the models, the next generation models, so that it's not just for us, like the like machine learning community, but also like people who have no idea of what tech is, people
Yeah.
who have no idea of what machine learning is, like they're just using consumer products, you know? So
Yeah.
I'm really excited about like this trend of like having research, sharing this research, and having this research really impact other products, like products that people really use like in their daily lives.
Yeah, that's definitely a great comment. Even Jeremy Howard in the fast.ai course echoes upon this in fact that the cutting edge of research is slowly shifting from research academia to engineering, because what a researcher really aspires to is put these in the hand of consumers, eventually in the hands of humanity.
Yeah, but it doesn't like don't get me wrong. It doesn't mean that researchers like should do production. It's like I'm not saying that. Like I'm not
Yeah,
trying to mix everyone
yeah,
in
yeah,
the same pot, but I'm just saying that yeah, we should keep in mind that the end goal is like yeah, building like the autonomous car, like building the next generation of like tech in your phone. Yeah, this kind of thing.
I think you, particularly from being from Hugging Face, are in this amazing intersection. Are at this amazing intersection where you can also work on a product and research and ship it to production via open source.
Yeah, and
Uh,
that's actually how we started like all these open source efforts. So it's like, yeah, like we doing science for the product, doing machine learning for the product, and we quickly realized that all the things we were building like are actually useful.
yeah,
Actually useful like for a lot of people. Like not only like just like the models, the machine learning part, but like also like more like engineering stuff. Like for instance, like work a bit like on a really small library called Knock Knock.
okay.
Um, which was like, so I usually use early stopping when I train something. So basically, except like a really rough estimate, you have no idea when the training is going to stop.
Mm-hmm.
So I was like spending weeks, nights, and weekends like monitoring my trainings and having no idea when it's going to stop. So I just like do a simple interface, a simple library that basically send me like Slack notifications when it ends. So I don't have to worry anymore. So I build it like basically this like for myself and like at Hugging Face like for internal projects. And it was like it's super useful for a lot of people. So like we released it. And like sharing this kind of knowledge, like open sourcing, sharing
Yeah.
is really like at the core of our DNA. And like it's really like the vision and the culture that drives us like when we're doing open source.
I'm sure we all are definitely fans of that. But to me, at least, I'm not sure what your thoughts are on that. There's something really satisfying about watching those loss curves for minutes, hours. Sometimes I waste a lot of time doing that. Just watching the
Yeah.
loss curves go down.
Yeah.
Now, coming to another aspect of Hugging Face ships pre-trained models as well inside of the repository. So there's a question by at Zayed Al Afai. Do you support any pre-trained models in other languages like Arabic? If no, any future plans?
So we are working on a multilingual version of DistilBERT. So that is not just focused on English, but I'm trying to make it work like in a multilingual setting. So like so in an XLM or multilingual BERT like setting. So it will be available like in more than 100 languages.
Wow. Okay.
So yeah, like definitely like there's definitely like a focus shifting on not working just on English and yeah, like trying to either like shift this what we learn in English to like low resource settings or languages. Or yeah, you're just like train multilingual stuff that are like multilingual by construction.
That's really exciting.
And yeah, that's really exciting. I'm really excited about like this line of work.
Coming to open source efforts at Hugging Face, there's again a question from the AMA section by at Stormtrooper, really nice username 1721. How do you manage a large open source project effectively, and do you have any guidelines for creating machine learning libraries? Maybe you could quote the knock knock one, for example.
Yeah, so that's a good question. And yeah, like managing a really large library is definitely something that is time consuming. Like I'm gonna lie, it's time consuming. Yep. And we have people at Hugging Face that are full time on this, like full time managing the library, answering to issues, like integrating new stuff. But I guess that the more like the library grows, the more it's about people and the community creating.
Yeah.
And like just for instance, like we have an amazing community. Like I just want to shout out that like we have an amazing community. Like just for instance, this week, so we had two additional models, like one from Salesforce. Okay. So Nitish from Salesforce, like he's one of the main author like on the CTRL controllable language model from Salesforce. He basically integrated CTRL by himself. We didn't even like help him to do it.
Wow. Okay.
And like another example recently is like Stefan, like a German, he's in Munich, like he integrated the German version of BERT, a German version of BERT. Like, and yeah, we didn't like had like little supervision on that. Like, yeah, we have an amazing community. People are contributing, and that's really what we encourage. We like seeing people like gathering and having positive interaction. Because again, like really, like our culture and the DNA is really about sharing. Yep. We believe that we can gather a community around sharing models, and it's not just about sharing. It's also about like making it available to the highest number of people. So like you have a lower barrier to like get into like playing with state-of-the-art models, you know. Mm-hmm. And another thing that motivates us, and like I'm super excited to see all this community gathering around this, because we have like this open source code. People don't have like to spend hours and hours, weeks, maybe like trying to reproduce results. Yeah. Like trying to re-implement things, trying to maybe sometimes like retrain something from scratch. You know, not a lot of people have like the compute power to retrain BERT from scratch. Definitely. And so having these models already available, accessible to everyone, it's a huge deal. It's a huge deal for us. And so since people don't have to focus on that, it's already there. You just have like run scripts, make sure it's like you have the correct figures, etc. Yeah. You can really focus on like
the bigger question.
Focusing on the bigger question, test new hypotheses, like test new models, build upon like what we call the shoulders of giants.
Yeah.
and really rely on what people have already built and focus on the bigger questions, so that also themselves can bring value to the community.
Got it. For sure. And I'd also like to mention, like, as I said, Hugging Face as an apple of NLP research. I really am amazed and respect the fact that whenever a paper or anything is released by Hugging Face, for example, even DistilBERT, there's the research paper that comes out, source code that's completely up to the software engineering standards of any best organization, along with the blog post, which also walks you through in a not so sciencey language in a relaxed fashion. So even people who want to pick it up can easily go through that and build on top of it very easily.
Yeah, something I guess that's something at least I think is driving us is the opportunity to have a community as open as possible.
Yep.
And one aspect of that is having both researchers and like practitioners, I would say, like in the same place, using the same tools and building upon the same tools. And one practical aspect of that is also teaching.
Yep.
Like it sounds really like super serious, but like how can you like make sure that people who don't know yet a lot of things about machine learning or like have a little experience, and maybe like they're more software engineers right now, but they want to play with machine learning models, how can you make sure that our library is as easy as possible for them to use?
Mm-hmm.
But also make sure that like the libraries has enough complexity for researchers to play with, like to get into the code, like to,
sure.
I don't know, like change the self-attention, add a new model here, like add a new, change the layer norm, whatever. Like
without breaking things.
Yeah, definitely. And like teaching is definitely part of it. So either we like releasing like blog posts to really explain like stuff in machine learning, and we always have like this backlog. I'm always thinking like what can be the next blog post, not necessarily like in a really science way, not like, because sharing knowledge is not just about like writing papers. You want to make sure that people can also like get into the community and contribute like as soon as possible.
Yep.
So yeah, teaching, like pushing like the latest and the best practices in terms of like both software engineering and machine learning engineering. And yeah,
I'd like to give a shout out to your Medium profile and even the Hugging Face publication, as they call it. Do check out the complete publication. Each and every post is definitely amazing there. Even if it's an older one, I'd highly recommend everyone to go through every post.
Yeah, there are like some old posts. Yeah.
Now you mentioned this briefly that it's definitely the case that not everyone in the community has access to a good amount of compute power, or at least multiple graphic cards. What are your thoughts on people developing applications on a small or maybe a single machine in the NLP domain? And do you think it's possible for them to produce competitive results now that we have this crazy competition in terms of compute power?
I think the question is on what? What do you want to be competitive on? Like, do you want to be competitive on the same thing as Google, same thing as Fair, Microsoft, Amazon? Do you want to be competitive in pre-training? Because like when you're independent researchers, I honestly think it doesn't make any sense, like to trying to compete with Google. Like you have to, I guess, like the easiest answer here is, yeah, definitely define what you want to work on.
Mm-hmm.
And if you're an independent researcher, it doesn't make sense to work on the same thing as Google or as Fair. Like people who have much more compute than you, even if you have the same idea, like you probably, I'm not sure you will have like the cash to burn, like to burn compute. I'm not sure you will have like the human resource like to develop your ideas.
Yeah.
So yeah, it's really about what you're working on. Then there are like so many things you can work on, like different than pre-training. Like there are like a lot of interesting research, like from the research point of view. There are a lot of research that is definitely doesn't require as much compute. Like fine tuning is already enough. And yeah, like other like for practitioners, like I guess like the credo is here is build something. When you're a practitioner, build something, like
Yeah.
you want to push something out, something that excites you, and it doesn't have to be really sciencey, research oriented thing. Like
Hot
you
dog or
can,
not dog app? Not hot dog app.
yeah, yeah, that's a super good example actually. Like yeah, that's a super like fun something that actually at least makes me laugh. And yeah, like take like yeah, something that inspires you, like you taking pleasure of building something, like using machine learning, and that doesn't necessarily like in
Yeah.
which you can be competitive, like without having access to like crazy amount of compute, just because you like don't want to compete with Google. It doesn't make any sense. Like yeah, let's like dislodge pre-trainings like to the big tech companies. It's fine, and I like this trend we have like in the community right now that like sharing is also like responsible. It's a responsible thing to do.
Yep.
Like in terms of like openness of the community, in terms of like impact on the environment. So yeah, don't compete with Google. It doesn't make any sense.
To also quote an example that I just remembered, there's this paper by Sebastian Ruder, to tune or not tune, where it compares if fine tuning is important or not. I assume that wouldn't take up as much of compute power, but it's definitely a good area of experimentation if anyone would like.
Yeah, definitely. I love this paper. I love reading this paper. I think it was at HCL this summer. Uh,
I don't remember, but I definitely think it was from this year.
yeah, yeah,
Uh,
definitely.
yeah. Coming to online courses, so Julian had this post about the 224N Stanford NLP course. What are
Oh
your
yeah.
thoughts on online courses to get a break into the field? Maybe your favorite online courses, and any tips to a person who maybe wants to work at Hugging Face but is looking at online education?
Actually, like in our team, we have a few people who don't have a like really formal
Traditional
background in machine
background.
learning. Yeah, like
Okay.
for instance, like Thomas like have a background in physics, like in quantum physics, I think. Yeah, he had a background in quantum physics, which is
For the
like super
audience,
far from.
he's leading the research team at Hugging Face. To those.
Yeah, Thomas is leading the science team at Hugging Face, and he didn't have like a really formal like he didn't get in PhD in computer science, like in NLP or machine learning. And I think he's doing fine. Um, yeah, so I guess like it's definitely possible like to. I'm not necessarily like just talking about like online courses. I'm speaking about like how can you like get into like machine learning without like super formal background in machine learning, super formal education in machine learning. It's definitely possible. There are like so many courses. Like reading papers is one way. Building something is definitely the way I recommend.
Mhm.
Don't just build something. Definitely read read as much as possible. Like online courses are great, definitely, because they definitely pinpoint to the uh, like good references at least, and like the main topics that are actually useful.
Mhm.
So that's a really good way to get in, because it gives an overview of of yeah what's happening,
Yeah.
why this kind of developments, and what like precedes what's the actual trend in transformers, etc. So yeah, online courses are great. Building something, definitely, I would definitely recommend building something. Definitely something that excites you, that makes you laugh, and you want to spend all your weekend building that. Yeah,
Go out
that's
there
my
and
advice.
create the state of the art hot dog or not hot dog app this weekend. what, what's your favorite online course recommendation? Maybe one or two, any amount.
I definitely like the Stanford stack of like the Stanford NLP course
Okay.
led by Christopher Manning. I definitely love this one. Like maybe if I can cite another one, there are a lot of like good blog posts. Sebastian Ruder has amazing blog posts.
Yeah.
I really like the podcast of Matt Gardner at Allen AI.
Mm-hmm.
That's a really good way so it's Matt Gardner and Walid. I don't remember his family name. Sorry.
Okay.
I'm so sorry about that. But yeah, like co-hosted with Matt Gardner and Walid.
Mm-hmm.
And yeah, that's a great way to hear the authors of the papers and discuss what are the hypotheses, what are the limits of their work, and what can be future improvements of future works. Yeah.
Got it. This has been an amazing conversation. My final question to you is, what best advice do you have for someone who's just getting started into the field? So machine learning or NLP broadly speaking.
The most reasonable advice I would say is not trying to do research at first.
Okay.
So I'm definitely biased toward doing research because that's pretty much what I do. And I do realize that that's definitely not the most reasonable advice to give. Don't do research when you start. Start by the basics. Read courses, read blog posts that have a more overview of things, that don't get into technical details without any explanations, or technical details that are not necessary here.
Yep.
So yeah, read a lot, start where you are, and build something. It doesn't have to be really complex. But that's something we really look into, when we hire, for instance, what past open source projects have you done, what kind of contributions to major libraries have you done. Mm-hmm. And there's definitely a trend in the industry when you hire is where to okay, the resume is good, how do they stand out? Did they build something, contribute to libraries, did they did research or whatever. Mm-hmm. So yeah.
This has been an amazing conversation. Before we end the call, what would be the best platforms to follow you and follow your work?
Yeah. First, thank you very much for having me. It was super exciting to talk with you and discuss all these super exciting topics. Yeah, the best platform is definitely Twitter. And my handle is Hassan S. Pasmoy. Maybe you can link it because it's difficult to spell it. But yeah, definitely Twitter is the way to go.
Okay. All right. Thank you so much again, Victor, for joining me on the show. And thanks to all the contributions to the NLP and machine learning community.
Thank you. Thank you so much, Sanyam, for having me.
It's really an honor to be talking to you on the show. Thanks again.
Thank you. Have a good one.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.